So again, to prove any identity, you want to make sure that we know the basics. The basics are, I'm going to put them in the notes so you'll have them, that cosecant x equals 1 over sine of x. Secant x equals 1 over cosine x. Tangent x, these will be part of the notes, equals sine of x over cosine of x. And the cotangent, it's 1 over tangent x, which is actually cosine over sine. That we really should know. Everyone should know that. Anyone who's taken trig, I shouldn't say everyone, anyone who's taken trig should know these. And the other one we should know is number 5, and that's sine squared x plus cosine squared x is always equal to 1. Always. Doesn't matter again if you're in degree mode, radian mode, any number you want to use, positive, negative, as long as the same number you use for the sine, the cosine, your answer is 1. So don't use sine 2 pi squared plus cosine 3 pi. It has to be the same value. Now, there are 2 more identities there on the board, 6 and 7. And those, I don't remember them. I'm going to derive them. I'm going to show you how simple to derive them. Take number 5, which is this one. And let me divide let's divide every term. That's an equation. Whatever you do to one piece, you got to do it to every one of them. So let me divide every one of them by sine squared. You say, why not cosine? I said, well, the next one will be cosine. What is sine squared over sine squared? What's cosine over sine? Cosine over sine, cotangent. Since these are squared, that'll be what? Cotangent squared. And what's 1 over sine? Cosecant, that's squared. That'll be what? Cosecant squared x. Is that one of the ones on the board?
Yeah.
It's number 7, right?
Yep.
Let me add that to the list now. I'll leave a space for 6. Try to match the number with the board. That's 1 plus cotangent squared x equals cosecant squared x. Let's repeat the process, but now instead of dividing by sine squared, we're going to divide by what? Cosine squared. Let's divide by cosine squared. Sine over cosine is what? So this will be tangent squared plus cosine squared over cosine squared, which is what? 1. And again, what's 1 over cosine? That'll be a secant squared. Isn't that equation number 6 on the board? Except they wrote the 1 first. It's the same thing. So 1 plus tangent squared x equals secant squared x. You know, if I want to have fun with this, I know you're all having fun with it. Watch this. I can even make it look different. What will happen if I move that 1 to that side? You get tangent squared x equals what? Secant squared x what? Minus 1. So you can, sometimes they give you that as an equation, new equation. It's really nothing more than playing with these. If I move the 1 to that side, what do we have? Cotangent square x equals what? Cosecant squared x minus 1. So we can sit down, play with this, and keep writing equation after equation after equation. Just playing with the algebra. It looks like we have different equations. It's not. It's that one. We just played with the math. If we understand these, if we memorize these, to prove something, it's not going to be that difficult, because this section proved that this is equal to that, or simplify the expression. So let me take a problem. Any question on this one? This page? Okay. Here's a question. Flip it. It's purple. Prove that tangent theta times cosecant theta equals secant theta. First, when you start doing your homework, there's no way they're going to ask you to prove that's equal to that. How are you supposed to prove it on the software? You can't. But what they're going to ask you to do, they're going to give you this to simplify it. So instead of saying prove, it says simplify this. And you're supposed to come up with that answer. So how do we do that? I found out the easiest thing to write everything in terms of sine and cosine. If you write everything in terms of sine and cosine, things will work out nicely. And the other thing to remember, you can only work on one side at a time. When you're proving something, you can't work on both sides. You got to choose one side and work with it. Usually the side that you want to choose is the ugly side. In this case, that's the ugly side. What's the tangent? Let's look on the board. Equation number 3. Sine over cosine. So take the tangent and put sine theta over cosine theta times cosecant. Look on the board. Cosecant, where is it? 1 over sine. Now use your algebra. You're multiplying two fractions. What do you notice about the top and the bottom here? They're the same. You can cancel them out. What's left on the top? 1. The bottom, cosine theta. Let's look at the board. What is 1 over cosine? That's secant theta. That matches that one. So by using these equations on the board, I just proved that this is equal to that. Let me try another one. Prove you know what? Let me go on the next page. Might require a full page. The next one.
Oh, fantastic.
Yep. There we go. I don't know if it requires a whole page, but it looks like an ugly one. So I'll save a lot of room for it. Prove that secant squared y, they're using y here, over cotangent y minus tangent cube. Oh boy. Equals tangent y. Again, I'm going to go to the basics. Secant is what?
1 over cosine.
1 over cosine. That's a squared. So it's 1 squared, which is what? 1 over cosine squared. Oh, y. I'm not using x, they're using y. Thank you. I'm going to say, why not? Cotangent. Try again. Better. Oh, yeah. Cosine over sine. And before I continue, let me just simplify this fraction. That looks ugly. There's the minus sign. When you have what we call a compound fraction or complex fraction, the easiest way to simplify that, the easiest way,
Multiply that over simple.
or you can, or go the outside over the inside, always. If you have a fraction divided by a fraction, the result is always the outside over the inside. You don't have to switch this to sine over cosine, do it. So what is sine y times 1?
Sine 1.
That's the outside. So on the top. On the bottom is the inside. What's cosine squared times the cosine? Cosine cube. I'm looking to see if that's tangent cube because I can't really tell. Yep, it looks like cube. We'll see. Now, let's look at tangent cube, which is what? Sine cube over cosine cube. Can I simplify that? Not yet. So let's put it next to this one. So I simplified, I took both of these, rewrote them in terms of sine, cosine, cleaned them out. Now what do you notice about the bottom? Same, so when you're adding or subtracting fraction, you want a common denominator. Lucky for us, we do have one. What is the top going to be? Sine of y minus sine cube y. Okay. Like I said, factor a sine out. What's left? 1 minus sine squared y. And just factor sine y out. You know what? There's two more equations we didn't put on the board.
The bottom should still be cubed, right?
Cubed, yes. Good, I'm making sure you're paying attention. Now, let's look at that equation. Just take a peek. Sine squared plus cosine squared equals 1. See that one?
Mm-hmm.
What will happen if I move the sine squared to this side? What would you have?
What we have now? 1 minus.
You have 1 minus sine squared, isn't it?
Mm-hmm.
So this equation, let me just write it down here because I have, so I'm going to take that equation and put it here. We had sine squared x plus cosine squared x. We said that's equal to 1. I can really derive two equations out of that. If I move the cosine squared to this side, I have what? Sine squared x equals what? 1 minus cosine squared x. And if I move the cosines, the sine squared there, I have what? Cosine squared x equals what? 1 minus sine squared x. So that equation, from it, I managed to derive two more. It's the same equation, just looks different. But look and see what you have. You have 1 minus sine squared. Isn't that this piece?
Mm-hmm. So
And that's equal to what? Cosine squared.
Just gotta be creative.
You get 2 of them here, and you get 3 in the bottom. See them? 2 cosines, 3 cosines. That should cancel 2 from the top and 2 from the bottom. So this will cancel 2, leaving you with 1 here. So you end up with what? Sine over cosine, which is what? And that's the tangent y. When I get to this section, I always tell people this is like playing with Play-Doh. You got to bend it, fold it, push it, turn it, and all this to make it fit the shape that you're looking for. And that's what we're doing, actually. We're just going through some of the identities, moving this here, bending this one, trying that one.
Yeah, so we cancel.
Again, on the homework, they're not going to say prove. They're going to say simplify this using a single trig. Simplify using single trig, that's your answer, tangent y. So this ugly piece right here equal to that. Let's try another one. I'm glad I put that on a separate page because that took the whole page. Let's go to the end of the book. I'll take some prompts from the end of the book.
I'm just trying to figure out these last ones.
Okay. Prove. I'm just picking prompts from the back. Let me pick something. Cotangent theta, secant square theta. Minus cotangent theta. I can honestly tell you, this is me the first time seeing it, just like you, your first time seeing it. So I never seen some of these. And they want that to equal what? I forgot which question. Was it cotangent theta, secant square theta minus cotangent theta?
Yeah.
They wanted to prove that's equal tangent theta. I'm going to take my advice. I'm going to say change everything to sine, cosine. Work with the ugly side. This is my ugly side. Take the cotangent. What's the cotangent equal to on the board? Cosine over sine. Times secant 1 over cosine, but that's a squared. 1 over cosine squared theta. Minus the cotangent, which is what? Cosine theta over sine theta.
I got lost at secant.
It's 1 over and there's just a square.
Number 2.
Number 2, the last one.
Notice I see, looking here, I'm multiplying, just right there. I'm looking at this as a fraction. You have 1 cosine, you get 2 in the bottom. This cancels one of these in the bottom. So what's left here? 1 over what? Sine theta,
Times cosine.
cosine theta. Minus sine theta, cosine theta.
Yeah, why it's multiple. The other thing.
Which one? When you cancel, that's a 1. 1 times 1 is 1.
Are we dividing by? Oh, wait.
Sine times cosine, sine cosine.
Oh, you've already multiplied them.
Yep. Don't get me confused. Doesn't take much to get me confused. Minus the cosine over sine. Now, what do you notice the operation between them? What is that?
Subtraction.
Subtractions. And if you're going to add or subtract two fractions, what do you need?
They gotta be like terms.
common denominators, like terms on the bottom, exactly. What can we do to this to make it look like this? Multiply by the cosine of theta. If you multiply the bottom by the cosine, you have to multiply the top by the cosine. So now the bottom is the same. I can use one of them. One minus, what's cosine times cosine? Cosine squared, yep. And let me go back to my cheat sheet. 1 minus cosine squared is equal to what? That's a sine squared.
Wait, don't go anywhere yet.
There's two sines on the top, one on the bottom.
Just keep
I'll come back. This cancels one of these.
Oh, they're both having the same one. Oh, he already subtracted them.
Oh, you tried to copy.
These are already, yeah, that was our common range, but he
And
skipped
that's
that and just made subtracted.
Tangent theta. I'll give you a chance in a few minutes to do some of them. So notice anytime you're adding or subtracting, you want to have a common denominator. In this case, my common denominator is sine cosine, so this becomes 1 over sine cosine minus cosine squared over sine cosine. I just took one step out and I jumped to this one. And 1 minus cosine squared is actually sine squared, and after you put that, start to fall apart. It's like a puzzle. When you get toward the end, you know these puzzles that have multiple pieces?
Yeah.
You try and match this one here. When you get to the end, there's only 6, 7 pieces. You know where they're going to go. Like boom, 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 boom. Once you get to that end, it moves. But to get to that point takes a while. So what kind of questions you might see on the homework? I'll do another one, then I'll let you try some. Instead of prove, I might ask you to simplify. So instead of prove, I'm not going to give you the right side. I'm going to say simplify this and tell me what the answer is.
Wait, how do we get the sine squared?
1 minus cosine squared.
Oh, so we have to take basically, yeah.
Yep, 1 minus cosine squared is sine squared. That's why you want to have these, as I said, you want to have these equations on a sheet of paper so you can always look at them and see.
Professor, from the red portion, below that, I don't see the denominator. I don't know. Yeah.
Well, this is sine cosine.
Yeah.
So to make this sine, this is cosine over sine. You don't have that. So if you need to add them or subtract them, you better have a cosine here. You better match this. So you got to multiply this by the cosine. And if you multiply the bottom by cosine, you have to multiply the top by cosine.
Yeah, but why the denominator doesn't become sine squared cos squared?
Because you're
I'm looking at that fraction. I'm only multiplying by the cosine. I'm looking at that fraction. I need to make the bottom just like this. I need a cosine, so I'm not looking at that one.
the bottom doesn't change.
Yeah, when you
subtract fractions.
Oh, when you subtract here, you mean?
Yeah.
No, when you're subtracting, the bottom stays the same, only the top. Remember when you, let me just,
Just use like a normal
Yep.
fraction.
Basically,
yep,
the lowest common denominator.
exactly. Okay, let me try one more. Then I'll shut the camera, I'll let you try a few of them. Simplify. This is what you're going to see. let me pick a cool problem. I think it's cool problem. And I'm intentionally using a lot of cosecant, secant, tangent to force you actually to memorize these unintentionally without you having to sit down going this over that. Secant, I'll use x. Secant x divided by how about cosine x minus tangent x over cotangent x. I want to simplify that.
Alright, so we change to cosine.
We're going to change everything to sine, cosine. Anything that's not in sine, cosine, let's switch it. Secant. 1 over cosine x divided by cosine x. And stay there for a second.
So with this one, you can't do inner over outer.
Oh, yeah? Yep.
There's over one.
Yep, exactly. That's why I said stay there. Tangent. What's a tangent?
Sine over cosine. Yeah.
Good. Sine over cosine. Cotangent.
Cosine over sine.
Cosine over sine. You want to have everything in sine, cosine. Now, the one on the right side is not bad. You're going, hey, I can use the outside over the inside, right? This is the outside divided by the inside. Outside over the inside. Told you I have a lot of saying, outside over inside. You'll hear that with my next song with, who am I going to sing this one with? Nicki Minaj. Here we go. Outside over inside. Sine times sine will make it what? Sine squared. Cosine times cosine. Now this one I can't do outside over the inside because I don't have a fraction here. Perfect. Make it over 1. Let me use an orange color for that. Anything is over 1. So now you do what? Outside over the outside, inside over the inside. 1 times a 1, 1. Cosine times cosine. What?
Cosine squared x. So you get secant.
No. Leave it alone.
Oh, because
You have fractions. You're subtracting.
So 1 minus sine squared.
So leave the bottom alone. Remember, these are fractions.
Oh, so that's cosine squared x with the 1 minus sine squared x.
Yeah.
1 minus sine squared x. Now you know where to look for that identity.
Number 5, sine squared x.
Number 5 is the one we're going to use the most.
Yeah, it's a number 5, cosine squared x.
Yep, you have that. Again, I'll just show it to you. Seeing is believing. 1 minus sine squared is what? Cosine squared. So you're going to have cosine squared x over cosine squared x. And what's that equal to? 1. Bingo.